All right, let's just dive right in. We're going to tackle a question that honestly sounds like it's straight out of science fiction, but it's actually at the very forefront of modern physics. Are space and time even real? Or is this whole universe we experience just, some kind of elaborate illusion? Let's find out. So, to get our heads around this, let's start with a little thought experiment. Just imagine for a second you're trying to explain the color orange to someone who's been blind since birth. How would you even do it? You might say, oh, it's a warm color, kind of like fire. But then they'd ask, what does warm mean for a color? See, their reality doesn't even have a slot for the concept of color.
And this is the whole point. You and this person, you're both human, living in the same world. But just because they're missing one sensory input, their entire perception of the universe is completely different. Their reality isn't your reality. In other words, reality is subjective. And if that's true for something as basic as a color, what does that imply for something as fundamental as space and time?
Now, this is not a new question. For centuries, brilliant minds, philosophers, scientists, have been locked in this huge debate about what the universe is actually made of. And it's a debate that really pits two totally opposite views against each other. So in one corner, you've got absolutism. This is the idea that space and time are like a fixed, rigid container that holds the universe. They exist whether we're here or not, and they're the same for absolutely everyone. And in the other corner, you have relationalism. This view argues that space and time aren't a container at all. They are just the relationship between things, and how we perceive them depends entirely on who's doing the observing. So, who's right? Well, to figure that out, we've got to look at how this incredible intellectual battle has unfolded over the centuries, starting with some of the biggest names in classical science. The whole thing really gets going back in the 1600s with the philosopher and mathematician René Descartes. He's the one who first suggested the universe could be mapped out like a giant 3D grid. A few decades later, Sir Isaac Newton takes that idea and just runs with it, making it the foundation of his world-changing laws of motion. But almost right away, a challenger pops up with a completely different take, Gottfried Leibniz. This pretty much sums up the absolutist view. For Newton and Descartes, space was the stage, and time was this universal clock, just ticking away at the exact same rate for every single person, every planet, every star in the universe. It's an idea that just feels right, Time waits for no one. But Leibniz, he argued the complete opposite. He said, forget the container. Space isn't some pre-existing thing. It only emerges because of the way objects are arranged relative to each other. So if you could somehow remove every single object from the universe, you wouldn't be left with empty space. You'd be left with literally nothing at all. Now, for his time, this was a wild idea, and for a long, long time, Newton's view pretty much won the day. And for about 200 years, that was that. The idea of an absolute, predictable, clockwork universe was king. It was neat, it was tidy, and it worked. But then, a patent clerk from Germany came along and flipped the entire chessboard over. In the early 20th century, a guy named Albert Einstein published his theory of relativity. And with that, this great debate wasn't just reignited, it was blown wide open in the most spectacular way you can imagine. Einstein's first big move was to introduce a totally new concept, space-time. He showed us that space and time aren't separate things at all. They're actually two parts of a single, interwoven fabric, a four-dimensional reality. You can't mess with one without affecting the other. And here's where it gets really crazy. Einstein proved that the faster you move through space, the slower you move through time. And this isn't just theory, it's a measurable fact. The GPS satellites orbiting Earth have to constantly adjust for this effect just to give you the right directions. So, if time can literally speed up or slow down depending on who's looking, well then it simply cannot be absolute. Einstein had just landed a knockout blow for the relationalism camp. But the story doesn't stop there. Not even close. In the last few decades, a new theory has been bubbling up from the super weird world of quantum physics. And it takes Leibniz's ideas a step further, suggesting that not only is reality relational, but it might be something we are actively creating with our own minds. It's called the emergence theory, and it proposes that our entire 3D universe, everything we can see and touch, even space and time themselves, isn't the fundamental reality. Instead, it's more like a lower dimensional projection, like a shadow that's being cast from a much more complex, higher dimensional reality that's the true blueprint for everything. Here's a cool way to try and picture this.
Imagine a really intricate crystal, but it exists in 8 dimensions, a reality we can't possibly perceive. But it casts a shadow, and that shadow, projected down into our familiar 3 dimensions, creates a pattern. Well, according to this theory, that 3D pattern, that shadow, is our universe. The fundamental particles that make up everything are just the points of light and dark in this cosmic projection. This, of course, leads to a massive question. If our universe is a projection, what's the light source? What's the projector that's taking all this higher dimensional information and turning it into the reality we experience every day? The answer, according to emergence theory, is consciousness itself. The theory suggests that, at its most basic level, reality is just a sea of pure information and potential. It's the very act of a conscious being observing it that causes this potential to collapse into the solid, physical world we know. And as bizarre as that sounds, there's actually real, compelling evidence for it from quantum physics. Okay, before you write this off, you need to know this idea is grounded in some of the most rigorously tested science we have. The 2022 Nobel Prize in Physics was given for experiments that proved the reality of quantum entanglement. This is the phenomenon where particles can be linked, and measuring one instantly affects the other, no matter how far apart they are. These experiments also confirm that particles exist in this fuzzy cloud of probabilities, a state called superposition, until they're observed. The moment a conscious observer measures a particle, it snaps from infinite possibilities into one definite state. Our unique brains then take in all these states and from them construct our own unique version of reality. So after centuries of debate, from Newton's fixed universe to Einstein's relativity, and now all the way to the quantum world, where does that leave us? What is the nature of our reality really? You can really see how the consensus has shifted over time. For 200 years, the Newtonian absolutist view was pretty much the only game in town. Then Einstein came along with relativity, and a relational universe became the leading idea. And today, the truly mind-bending evidence from quantum mechanics is pointing toward a reality that isn't just relational, but is fundamentally dependent on us, the observer. So here is the biggest takeaway from all of this. The cutting edge of science is telling us that space and time are not fundamental. They are not the fixed stage that we're all just acting on. They seem to be emergent properties of a universe that we are actively participating in creating, just by this simple act of observation. Reality isn't something you find, it's something you help bring into being. And that leaves us with one last, really powerful thought to chew on. If your unique consciousness, your very act of paying attention, is what collapses infinite potential into the one reality you experience, then what reality are you choosing to observe into existence?